Okay, so we have done hyperparameter tuning with the XGBoost model. We have considered base score, maximum depth, booster, objective, eval metrics, and early stopping routes. So this is the output of our XGBoost model. So as we can see here, test accuracy is around 85.71% and train accuracy is around 88.88%, which is excellent. So as we were having very less data, we were having lots of constraint, but we have achieved very good result enough. So that's it from my side. So I'll hand over next slides to
Amruta.
my friend Amruta. Thank you.
Hi, thank you, Emalu. Next slide, please. Here I'm going to explain deployment strategy. Python Flask is an open source Python library that makes it easy to create custom web app for machine learning and data science. It is classified as a micro framework because it does not require particular tool or libraries. It has no database abstraction layer from validation or any other components where pre-existing third-party libraries and provide common function. PaveVio provides a series of imperative functions to obtain user input and output on the browser, turning the browser into rich text terminal and can be used to build a simple web application or browser-based GUI application without the need to have a knowledge of HTML and JS. PaveVio can also be easily integrated into the existing web service. PaveVio is very suitable for quickly building applications that do not require complex UI. HTML is used for making a structure of the website to take input and manually from the user. CSS is used to describing the presentation of HTML documents and styling the HTML structure to make it looks good. Next slide, please. Over to Harish.
Harish, are you there?
Yes, I'm back. Welcome back. I'm Harish. I'm going to give you a brief explanation about model building and deployment part. I'm going to explain the coding part for that. We have imported the required libraries for the data pre-processing, that data modeling, data evaluation, and for model deployment. We have imported all the required libraries for data pre-processing. We have imported the libraries such as NumPy, Pandas, Matplotlib, Seaborn, Simple Imputer, Prime Text Split, Confusion Matrix, Accuracy Score, Lazy Classifier, XGBoost Classifier, and Label Encoders, and some other libraries as well. We have created a specific path for our project, and after that, we have imported the data from localhost to the Python. Yeah, here you go. You can see how you imported the data by using pandas. Yes. After that, we are going to look at, is there any unique values presented in the data set or not? Yes, we have unique values presented in a particular column called chemo given initially. The unique value presented in the chemo given initially was 6 circle of CDBB plus CTX. Here you can find the space involved there. We have to remove the space. Yes. And again, we have to check whether the space was removed or not. Yeah, here you people can clearly observe the space was removed. Yes, you can see here the data is completely not having any unique values because we removed that unique value in the chemo given initially column presented in dataset, right? Okay. Then we renamed survival and chemo given initially columns. We have to rename the columns for our own convenience, right? Yeah, we used head function for visualizing the data presented in the data set. We use shape function for visualize the shape and all the things. Yes, we use describe function for visualizing the statistical conditions. It will give the better understanding of the data. Yeah, here you can see mean, median, and all stats of the data. And we use is null function here to find is there any null values presented in the data or not. Here you can clearly observe there are 10 null values presented in tumor size column. We have to replace those values by doing imputation. Yes. After later on, we have done pandas profiling. I think my friends already explained about that. Then chemo given initially in that column, we have null values. We have to really replace that NIN values with NIL. Then we are going to do imputation part. Here we use simple imputer library for doing imputation. In tumor size column, there are a lot of categorical data. We have to do the imputation for that. Yes, yeah, we written those lines of code for doing the mode imputation for that because that is the categorical data. And then in tumor size, we have the data in the form of strings and included with unwanted symbols, unwanted semicolons. There are some symbols like greater than, less than, and some mathematical functions like addition, subtraction, and all those things. We have to split the data and we have to make the data clear and balanced. The phenomenon of creating the data into a numerical form and into a balanced data set we have done with replace function. We used here the split function and all those things. Yeah, here you people can see. Yes, that's fine. That's fine. That's very. And then the phenomenon of converting categorical data into numerical data, we have to do one hot encoding for the columns like HPE, chemo given initially, surgery, and all the columns. Here you people can see the data converted into encoders. In categorical data, basically we have nominal data and ordinal data. For ordinal data, especially we can do the label encoding. Yeah, here in the column stage, we have 1A, 1C, 2A, 3C, 5A. These are the stage which is in the order. We can call this data as a ordinal data and then better use label encoders. That's why we use label encoders here. Yes. Then there are some columns which are not giving any results and maybe they will affect our model. That's why we drop some columns here. You people can clearly see what are the columns we have dropped in here. Yeah, we drop in the columns relapse time. Okay. Then after removing the data columns from the data set, we have done yes, we have to look at the data types of the data set. Yeah, we have converted our data set into the float forms because we are going to dump our data into yes. Here we have done the train test split because we clear the data and we done imputation, we done all the categorical conversions. Here we use lazy classify functions as we already told about lazy classifier is the best model to identify the best accurate machine learning model. Out of those, yes, here you can see the XG booster classifier is the better accurate model. That's why we chosen the top model as our model and we dumped our data into the XG booster classifier. Yeah, here we use some parameters to tune the model. These are the hyperparameters. We use it to tune the model for better accuracy, right? Yeah, we are evaluated our data set, our model by using confusion matrix here. Yes, we fit the data into the model. You people can clearly see the code, what we have done here. We just use a confusion matrix to find the accuracy of the model. Yes, here you people can see the accuracy of the model. We have test accuracy of 85% and train accuracy of 88%. This is the excellent model because there is not much difference between test accuracy and train accuracy, right? Yes. This is the model building and let's jump into the deployment part. Yes, we have to open Anaconda prompt and we have to give our file there to get some IP address. Yes, we are writing some Python code here. The code will go to the model, and model will go to the results. Model will give the results. Yes. Yeah, wait for 10. Yes, this is the IP address we have. We have to copy this IP address and we have to paste this IP address in the browser, which we have already done the deployment file. Yes. Here, what is the age of patient? We have to enter the age of the patient, right? This is the 56 years age. What is the cause? What is the stage of TNBC? What is the tumor size? Tumor size is 2 centimeters. Surgery has been done. Chemo given initially 6 circles of that. You have to basically you have to yes, return of TNBC cannot occur. Based on the historical data, we can predict whether the patient will be going to get the TNBC or not. Okay, thank you. From here, I think Sindhu will be going to explain. Sindhu, can you?
Thank you, Harish. So I would like to conclude our project and on the TNBC, the analysis and the predictions we have done by using different models and also the inferences what we are able to get. So first, this model helps the medical team to predict the reoccurrence of the TNBC. We have taken various features from the secondary data source which we were available, and from that we have identified that age, stage, surgery, tumor size are the highest contributed to the TNBC cancer this thing. Also, there are many treatments that were given to the TNBC patients, right? In that, we identified that chemo plays a major role in the relapse prediction. So you may get what is the doubt of relapse in the sense is reoccurrence of the cancer. So chemo plays a very major role in this relapse prediction. And we found that improving the chemo treatment at early stages, as we have given you number of stages, right? 3 to 4. So if we are able to give this chemo treatment at the early stages, we are able to reduce this cancer risk at very predominant role. And TNBC relapse prediction is done with the help of our modern machine learning algorithms like the XGBoost. There were many algorithms which we have tried, and we found that yes, our TNBC we are able to predict this TNBC with the help of this machine learning, given the best predictions. Kudos to data science for that. And also there are many treatments for TNBC patient and for the relapse cases. So at what stage the relapse can be occurred, and at what stages, and at given the what treatment the relapse will be occurring. We found that our machine learning can be a very good help in deciding the line of the treatment. That's all for the conclusion. Next slide, please. Yeah, now future scope. Our data science, as we said, we are kudos to data science for giving this very much important information in predicting in analysis. And as we know that it's very sensitive medical area, we would like to give the future scope to the medical people in identifying more researchers and also finding the best treatments. In this way, this model allows the medical team to check the reoccurrence of TNBC and provide the treatment accordingly. This model helps the doctors to identify the factors affecting the relapse, which will be helpful for future researches on TNBC. Yeah, we identified that there are 5 features, right, which are mainly important. So, taking this as a base, we would tell doctors in the medical team to enhance their treatment, which will be streamlined to this features, and also they can improve better treatment, and this can be added to the future scope. Also, by using this model, there is high chance of minimizing the risk management and reduces the time and effort of the doctors. That's what we give to the future scope to the medical team and all. And any doubts?
If you have any questions or queries, please ask. We will feel free to answer those queries.